welcome to another episode of DECIDEthought. I am your host, as usual, John Heemeyer. Clearly, those of you who clicked on this video understand that we will be talking about a lost or forgotten rule of mathematics. In specific, today we will be talking about the rule of invisible numbers. Now, there are actually multiple invisible numbers, but we will be focusing on the numbers that follow this rule specifically. The rule of invisible numbers is basically that whenever you write a number, such as the number 7, there are many other numbers which are compounded with it that we simply do not see because we don't need to write them. Now, most of these numbers are simply ones and zeros. For instance, 7 minus 0 doesn't change the actual number. The minus 0 does not need to be written. 1 times 7, once again, it doesn't change the value of the number, therefore the multiplied by 1 is not needed. Same with dividing by 1 and raising it to the prime power. Each of these actually exists within every single number. We simply never have to write them. So the basic rule of invisible numbers is if a number, when combined with a mathematical function, causes no change in the number it's being connected to, the number need not be written. Now, some people might think that it stops there, but it actually goes quite a bit further. Namely, what you see right now can continue ad infinitum. For instance, and what makes this even worse is that this repetition is also included on each of the individual ones and zeros that are written. Now, as stated previously, there are other forms of invisible numbers. This is simply the type that follows the rule of invisible numbers. One of the other invisible numbers is quite simply when you try to find the square root of something. When you try to find a square root, the number 2 does not need to be written. However, if you try to find the cubic root, the 3 does have to be written. Anything above the square root or below the square root, it must be identified. There is one final type of invisible number. This invisible number holds specific importance to me, as back when I was still in grade school, my teacher at the time had put forth a challenge to the class. If anybody could write a formula that was true, that he could not prove as true or prove as false, then we will get an A on the next test. My solution was simple. This was my solution. It is a true statement. The reason that this worked in this specific instance is because we were learning about the other base systems, most specifically binary, hexadecimal, octal. Naturally, I assumed that there will be other base systems than just 2, 8, 10, 16, etc. Now, the invisible number we're talking about here is called the base system number. In normal mathematics, so long as the writer and the intended reader understand that the numbers are written in the same base system, the base number need not be written. It is an invisible number. The book we were learning from never stated this. The instructor never stated this. Therefore, this ended up being true. How? This uses the base 4 system. So 2 plus 2, in base 4 we start at 2, go forward 1, 2, add the new digit, and put the 0. Therefore, using this system, 2 plus 2 equals 1, 0. 1, 0 in this case means 4, but it's still written as 10. Normally, if it is believed that the writer and the reader will not be using the same base system, such as decimal, it is required to actually indicate what the base numbering system is. This is done by writing the base number at the lower right hand corner of each number present, as such. This makes this statement perfectly true. However, if I had written it and meant it to be the standard base 10 system, this would clearly be a false statement. Fortunately for me at the time, neither the instructor nor the book had specified this rule, so I ended up getting a 100% on the next test. So that's not only the rule of invisible numbers, but also a few additional numbers which are occasionally invisible, more by convention than by any actual rule. Now, normally, we leave it to our viewers to determine if this is information which they find to be useful. However, in this instance, we will be referring back to this for some of our future episodes. And in the end, it will be up to you to decide whether or not our work is worthwhile.